Hello everybody. Today let's take a look at nth roots. Now you've heard of square roots, but there are also other types of roots we could take. We could take cube roots, fourth roots, 100 roots, as many roots as we want. But to help us understand that, let's look back at some square roots. Now here we have 25x squared. We know that 25 is equivalent to 5 times 5, or 5 squared. So we know we can pull out a 5. And we've got this x squared here. That's going to give us a pair of x's, two x's. We know we can pull out. So this square root of 25x squared gives us 5x. Let's take a look at 12y cubed. 12, well, we know that would be equivalent to 4 times 3. This 4 would be the same as 2 squared, or 2 times 2. We know we could pull that out of the square root, and we'll be left with this 3 inside. Now we've got y cubed here. We know this gives us 3 y's, which would have a y squared with a y left over. So we know we can pull out 1y, and we'll have 1y left over. And here we have the simplification of that. All right, now taking the same concept, let's apply that to a cube root. All right, we know that 2 cubed, that would be the same as 2 times 2 times 2, which would give us 8. So the opposite of cubing something would be taking a cube root. Now, whenever you have a square root or a radical symbol here, the number up here is how many roots you're taking. So here we have cube root of 8. Now, instead of looking for something that's squared, we're going to be looking for something that's cubed, or we're going to be trying to match groups of 3. So this 8 here, that would be the same as 2 times 2 times 2, or 2 cubed. And since we have a group of 3, this is going to equal 2. Let's take a look at another example. Here we have a fourth root. Now this fourth root, we're going to be looking for things that are to the fourth power, or groups of 4. So inside our radical we have 32x7y8. Let's start with the 32 here. Now I know this 32 can be broken down into 16 times 2. And I know that 16 is 2 to the 4th. So 2 to the 4th, or 2 times 2 times 2 times 2 times 2. And that gives me a group of 4. So I know I can pull out a 2 from that, and I'm going to be left with a 2 inside the radical. And don't forget to leave your 4 on the outside, because we're taking a fourth root. Next we've got x to the 7. Well, we know that's basically the same as 7 x's, right? That would be 1, 2, 3, 4, 5, 6, 7. So shortcut, I know I can pull 4 from that 7, and that's going to give me nx right here on the outside. Now I am left with 3 x's remaining, so inside here I'm going to have x cubed. And remember, for every group of 4 I'm pulling out 1, because I'm taking a fourth root of x to the 4th. Now looking at this y here, I know I'm going to be looking for groups of 4, so I can tell, I don't have to write out, I could write out y times y times y times y times y 8 times, but I know y to the 8th is going to have 2 different groups of 4s. So since I have 2 different groups of 4s, on the outside here I'm going to pull out a y squared, because I have 2 different groups of 4s with nothing left on the inside. So my final answer is going to be 2x squared, sorry, not x squared, 2y squared with the fourth root of 2x cubed. So you've already learned that when you have a square root of a negative number, that it does not exist, or it's imaginary, right? Because we can't square a negative number. Like if we had negative 1 squared, that would be a positive 1. If we had negative 2 squared, that would be a positive 4. no matter what, whenever you square a number, you're going to end up with a positive. But what if we took the cube root of a negative 1? Is that going to be imaginary as well? Well, let's take a look at some of the difference. Here, when we had a squared term, we always ended up with a positive. But what happens if we took negative 1 and we cubed it? Well, that would be negative 1 times negative 1, which would be positive 1, times negative 1, which would be a negative 1. So when we cube something, we still can get a negative. So the cube root of negative 1 is not going to be imaginary. It is actually going to just be negative 1. So with that new information, you might ask, Mr. Zonker, if we can have nth roots that are imaginary and some nth roots are not imaginary, how the heck am I supposed to tell whether or not the number is going to be imaginary or not? Well, it's actually pretty simple. You can tell based on what nth root you're taking. So, for example, if we have a square root, a fourth root, a sixth root, these are all going to be imaginary. And the reason is, whenever we put something to an even power, it can never be a negative number. So whenever we have an even root, it's always going to be imaginary, assuming that inside the radical is negative. In the case that we have an odd number for our nth root, like 3, or the fifth root, or the seventh root, or any other odd root, these are going to be real numbers. These are not going to be imaginary. Again, kind of like the negative 1 cube that we had, you can put anything to an odd power and still get a negative. So anything to an odd with an odd root will be real, and anything with a even root and a negative inside the radical will be imaginary.